are, what's the definition of it, how the modern software delivery factory looks like, and what are the things we should do to get there fast and agile way. We're going to talk about pipeline as a code, some of the tool chain aspects of DevOps. As you guys know, there are plenty of tools in this area, and sometimes it becomes harder to choose which one to choose in terms of what we are trying to accomplish. We'll go over some of the examples around those lines, and then we'll talk about infrastructure as a code and some of the definitions around things like Puppet and Chef, and we will conclude with some of the best practices in the industry with my last 14-15 years of experience around automation and DevOps. All right, let's move on. So this is a pretty animated slide, but I will give you guys some time to digest what is there. This pretty much shows how the software delivery factory should look like. Anybody who's coming from a manufacturing background would easily understand in terms of how the automation really helps in delivering faster products in a manufacturing world, but in the software industry, we end up struggling with a lot of manual tasks when from the time you check in the code as a developer to the time it goes to all the way to production and post-production issues and things like that. So we'll go over some of the details in next few slides, but what this slide basically telling, any of the yellow thing that you see, yellow stickies, these are stories which are coming from a customer, coming to the product management, and all the way it's going to the agile team, separate agile team that you see this blue thing rotating. These are separate agile teams. These are integration points. All of that has to be automated from the new features, legacy features perspective, and then integrated into single instance, or maybe a staging instance, before it goes all the way to production to the customers, and customers can start using it. And it goes in a cycle, and it should be much more automated. And except this yellow sticky part where we have to prioritize some of the stories, all the blue things can be easily automated from the time you check in the code to the time it goes to the production machine. There's a lot happens between these two things, right? So build, deploy, testing, reporting, staging deployments, and all the way to production. So all of that, how that can be done. So what the benefits of doing a software development in a factory model or an automated factory model is that you get a full traceability of the work done by individual teams and individual owners, and what is being delivered, what's in the pipeline, what is not being delivered, and if anything is failing, it will show right in the dashboard saying that, hey, this particular check-in has failed certain amount of test and the code coverage has been reduced and so forth, right? And it makes teams more efficient, more agile. It gets the work done and deliver early and often. So that's a key aspect of CI/CD pipelines, and that's where it gives a huge return on investment on this automation stuff. Also, if you have end-to-end automation, you can easily roll back in case of some production issue or some failure happens at the last minute, which was not captured by the CI/CD pipeline. And it's really, really important.
I'm sorry, JEET, can you please make your presentation to the full screen?
I'm sorry?
Can you please make your presentation to the full screen?
It is a full screen, isn't it?
No, we say like a template of presentation.
Okay. All right, let me share the entire screen. Can you see now?
Yes, it's okay now. Thank you. Sorry.
It's okay. So yeah, so you guys probably have missed the animation, but this exactly I was talking about when the things comes from customer to product management, and it goes to the prioritization between agile teams that you see this in circles, people sitting like 8 to 10 people. You don't want to have 14 people in an agile team. You want to have two teams which can can eat not more than two pizzas, right? So we call it as a two pizza teams at Amazon. So you want to have not more than 8 to 9 people in the team, at the max 10 people, and those teams are individually responsible for those CI CD pipelines for their own product, which can be integrated as a new features or legacy team before it goes all the way to customers and other environments. So it's a kind of a cycle that I was talking earlier. Everything in the blue here can be easily automated from the build, deploy, testing, reporting, and all the way to production. Anything on yellow is more of a prioritization effort that has to happen on an ongoing basis, right? And I was talking about the rollback scenario. So many times we see that many sites are down due to some issues happen, or some release was done which was not efficient. So when we have automation, it's easy to roll back to the previous release by just executing the entire automation within a few seconds and getting the results, right? And it becomes really, really important when it comes down to co-located teams. Let's say you have teams across the world. I mean, I've been to situations where I have managed team in India, I have managed team in Ukraine, Russia, China, and many parts of Europe, right? So if you have those situations, automation really helps to get the work done, and it also gives you visibility on what work has been done in the remote location by looking at those test scenarios, test coverages, what check-ins are being done. The pipelines gives you end-to-end traceability and full visibility into the entire software delivery model, which can be 100% automated. Let's move on. I think I already talked about this. One-click deployment once the release criteria is met, and you will see that some of those criterias that I was talking about in the future slides, where you can simply look at some of these acceptance criteria, code coverages, static code analysis, and test case coverage, all of that. And if you see everything is smooth, you can simply click the button, and the code will go to the production instance. So this I already talked as well. Let's move on. So I was talking about 5 to 9 people agile teams, right? And we call it as a two pizza teams at Amazon. It's very important to not to extend or not to have expanded team within the same agile team model, because that reduces the efficiency, it reduces the traceability and visibility, and you can't really efficiently produce enough story points when you are working on the agile model. So this Scrum team should consist of a Scrum Master, of course, the product owner or a product manager, and some certain business analysts, few engineers, some quality assurance testers. And these quality assurance tester has to be automation specific. So, that consists of the entire Scrum project team. So anytime the new story comes in from the customer, either that's a bug fix or it's a new feature, it goes through the cycle of not only just development, but also one of the definition of done that I usually recommend to have 100% automation for any new feature is being added. That really helps out later on if we are having an iteration of that feature to be delivered to the customer. It really becomes easy to test everything through automation then, as compared to relying on the manual resources and manual aspects of things, right? So, so in the previous slide, or the first slide, which was talking about the factory, right? You saw the blue rotation within the agile team. Everything was automated. This is that expanded version of that rotation. So what comes in the CI/CD model is build, provisioning. I call it as a deployment too, testing, reporting, and analysis. And it goes in a cycle. When the code is being checked in, it goes to the build, deploy, test, report, analyze cycle. And what these things consist of, right? So build consists of, you want to have a continuous build system like Jenkins. If you are into Java, use Maven or Ant. And if you're into if you're into like a .NET environment, NCover is a great tool to have a code coverage. Sonar, TestNG, JUnit, static code analysis, you name it, right? So you want to have all those kind of tools to be integrated into your continuous build system. So anytime the code is being checked in, it runs through not only the build and the compilation, but also static code analysis, the code coverage, how much coverage is being done from the unit tests and so forth. You want to see all that in your build component of the CI/CD model. And then once the build is done, you want to go through provisioning or deployment, right? So you want to have that artifacts which are being compiled and built through the build system to be deployed in certain dev environments or testing environments. And that can be done through configuration management like Puppet, Chef, Ansible, Cloud Foundry, or many of AWS tools like CloudFormation and stuff like that. So you want to have those deployments being automated as well. You want to have a multi-layer test execution on the testing aspect of it. So, in the previous slide, I was talking about the testers. If we hire the right resources, if we have the automation skill set within the Agile team, these resources can automate any new feature that is being developed by developers and getting some of the automation going not only at the UI level, but also at the API level and the all layer of testing, right? Functional reliability, performance, security scans, or regressions, anything that has to be automated. These folks and this component of CI/CD can easily get things moving. And then reporting, right, which is a very important component of CI/CD, and that goes back to what I was talking about, the visibility and the traceability of the entire system. So what it does basically, it takes it captures the data points from build system, the deployment system, testing system, and start populating in some sort of a dashboard, right? So it shows you the visibility of the pipeline, where the code is being checked in, how it is being tested, what metrics are being captured, and what are those results, right? So it takes data from Jenkins, it takes data from Sonar, it takes data from any tool that you are using, and you can actually design that reporting aspect or customize it for your own need to get that automation going. And you will see some of the examples in the future slides. And then analysis, I call it as a smart CI/CD, where now you already have a data, right, from the report. What you want to do, you want to integrate that data across your software development lifecycle and other tools like Jira, CRM, and have some definition of done and definition of release. And once you have those definition of release, then you can easily automate the entire cycle of deploying into a production instance, right? So the code gets checks in. Once the analyze, let's say analyze has a checklist of the code should be written by this and this date, and the code coverage should be above 80%. The third criteria could be no test should have failed. The fourth criteria probably can be a performance metrics that can be measured, right? And if all of those metrics and criteria met, it will automatically deliver to the production instance, since it already captured the data, analyzed the data, double checked the data has been validated through the definition of done, as well as other aspects of it. So it will automatically deploy the code into your production instances, or maybe staging, right, wherever you want it to be deployed. And that is all custom aspect of CI/CD that you can assume. I know there's a lot of data here. We'll open up for questions at the end. All right, so going further deep into the infrastructure of CI/CD, how that should be implemented. So taking those build, provision, test, report, and analysis, there are three sections of it. Basically, you need the automation infrastructure for getting the build and the provisioning going. So you want to have some tools like configuration management tool like CloudFormation or Cloud Foundry or things like that. For provisioning, for build, you need Jenkins or some other CI/CD or build provisioning tools that you want to have. And you want to tie that together very tightly, because once the build is done, you want to have the provisioning to be kicked off immediately, right? So you want to have very solid or rock solid automation infrastructure to where people can take the latest build, provision it manually if needed, and also the automation aspect of once the code is being checked in, build is done, the provision triggers, and it does it automatically. Also, from the test side, I have kept it in a separate category here, because test can be huge, especially for the legacy product where we are not using any microservices. That I've seen products which which has 10,000, 15,000 test cases in it. And you want to have that test automation being rock solid and consume across various types of tests, not just the functional or regression testing, but also the performance testing, reliability testing, scalability testing. All of that has to be accommodated within this test automation platform. And then the dashboard or release dashboard. Once we ran through all of that, you will see any data which need to be captured through across these builds can be captured in the report analysis phases. This can capture the data and show in the dashboard, and analysts can take the data, analyze it, make decisions, show go or no go decisions. All of that can be done in analysis, and it can be done in an iteration, right, as agile. So when the product releases, all of these validations are being done, sprint analysis are done, it says go, hey, deliver, right? So all of that can be done. But the key of this slide is having a rock solid infrastructure and the automation in place. Without rock solid infrastructure and automation, CI/CD does not work, right? Because there's a lot of manual task within it, which doesn't really give you the feeling of continuous delivery. All right, so I'm not going to spend too much time on this slide, but what it tells you that I've taken this reference from one of the blog online, where it says that how agile and how DevOps has changed the testing economics. Before agile world, this pyramid used to be upside down, meaning we used to have most of the manual ad hoc test, then some automated UI test, then automated API test, and the last were unit testing. But with the agile and DevOps, this is the way to go. Your 90 or 85% of the test case should be automated unit test, right? Remaining 10% should be API, automated API test. Then the GUI test, and very few which can, the test cases which cannot be automated or very hard to automate, that should be less than 4% of those test cases should be manual and ad hoc. So this is a way to design your testing frameworks when you are working on monolith applications or legacy applications. Things are different in a microservices or smaller applications, the newer applications which are developed in last couple of years, where development teams are making those decisions and doing more and more unit testing and more API component level testing, and they are not relying on manual ad hoc and automated GUI testing, and that's the way to go for any automation. Yeah, so this tells you the technology facing tests are in the bottom of the pyramid and the business facing tests are in the top of the pyramid. So the focus should be on the technology facing that usually addresses the business facing and so forth. Unless there's some exception or some exception cases where we need to have some manual test cases. This is the example of CD pipeline, and it gives you the holistic approach on how to do software development lifecycle. And taking whatever I have explained in last few slides, how the code, this is a product code on the top. This is a version control where everything should be stored, not just the product code, but also the application environment and configuration. And we talked about configuration management in last few slides, like Puppet, Chef, and Ansible, and CloudFormation, and all of those can be stored in some sort of a version control. Same thing about the testing environment and configuration. Anything to do with automation, test cases, or anything to do with regression, all of that can be stored in version control. And that's where the concept of infrastructure as a code comes in, right? So not only your product code, but everything else in your infrastructure should be stored in a version control as a code, right? So it can be reused, reformat, and reconsumed by various use cases. So going back to this product code, once the code is being compiled and built, it goes to the build system and then goes to provisioning. It takes the latest application environment and config management, like Puppet, Chef we talked about. It takes all of that data and deploy into certain environment. And then it goes to the next step of testing and automation testing. Anything which we talked about less than 4%, there's a manual test cases, complex test scenarios, not automated. Those can be executed by manual testers. Anything which is automated can be automatically triggered right after the provisioning is done. right? And it can quickly verify the legacy defects and whatever is need to do based on the definition of done and release criteria. And it takes all of that environment and keeps on updating to the test environment for the future purposes. And all of these build, application environment, testing, deployment, everything is being stored in some sort of a database, and it shows on the dashboards where you can actually not only report but also do some analytics and metrics, similar to what we talked about in the last slide. But this shows you the example of how you can take that infrastructure and have some examples around and implement some of these pipelines in a seamless way and have those dashboard being recorded. All right, these are another few examples of pipeline. Pipeline, CI/CD pipeline doesn't really have to be just the entire end-to-end. You can also have a separate pipeline design for at the component level, at the integration level, and the production deployment level, and then integrate these pipelines across. So in other words, one pipeline of a CI/CD from build to deployment of production can consist of multiple sub pipelines, right? So they can be a build pipeline, then the deployment pipeline, test pipeline, a reporting pipeline, and in compensate, the parent pipeline will integrate everything together to get things moving. So in this particular slide, we're talking about component pipeline where the code is being checked in, compiled, unit tested, assembled, and all of those steps are being automated, including the rollback steps, right? So if something failed, it rollback changes, notify to the developers, and come back to the slide. The integration pipeline, once everything is being successful from the compile to unit test to assemble artifacts and uploading artifacts into some sort of a artifactory or nexus, it notifies to developer. Then it goes to the second pipeline where it checks for the versions, download the artifact, whatever is being uploaded here, assemble unit testing, increment the stages, smoke test and everything for acceptance test, and it shows you all such type of testing is being passed. At any given moment, if any of these testing fail, it will roll back the deploy, and all of that can be automated, right? So without any manual intervention, and then notify the failure, goes back, right? Doesn't go to the next step to the production to deployment. If everything goes green, then it goes to a success message and then deploy incrementally to production with the blue-green deployment methodology or anything that you wanna do, right? Or smoke testing, immune system testing, all of that can be tested right after the deployment to production. Some of these are really important because these steps are some of the things that everybody does it manually, but these can be automated from the post-deployment perspective, that nothing is gonna break and stuff like that. And again, repeating myself about the rollback, if you have a full automation, rollback becomes a matter of a click rather than just struggling and figuring out why it failed and how we can make the site up and running again and again, right? So automation is a key for the pipeline. So I was talking about the DevOps tool chain, and there's several, and I would say hundreds of tools to choose from when you talk about having the CI/CD pipeline implemented. From the time where you want to make decisions on CI/CD tool or build tools like Jenkins, Bamboo, Cruise Control, and stuff like that, to also the CI servers, which most of the time build tools and CI servers are same, but many times, let's say if you are in a Microsoft Technologies doing .NET, then you won't have much support. I mean, you can do it in Jenkins and Bamboo, but there are not many plugins as compared to Java. So I've seen many developers using MS Build to get the build system running and then integrating that with Bamboo for the rest of CI and CD, or maybe integrating with Cruise Control or Travis, right? So you have to make a lot of choices here, from the source code management to build tools, the CI testing frameworks, and what you want to use for the packages and binaries, and then configuration management we talked about, and then deployment environments and monitoring, which comes day two operation once the code is being deployed. How and what tools can be used to monitor the system whether something is not looking right, including performance, scalability, and reliability, right? So this shows you the entire pipeline right in the middle with the green boxes, how that should be done. And also these steps in the pipeline which tool you can choose on the top and the bottom of the slide, where you have a lot of choices to make. And based on your use cases, based on your application environment, based on the culture, you have these decisions to make. And also it depends on the state of automation within your organization, within your application, how much automation you have. Based on that, you make all of that decision and then integrate everything together to make one big pipeline, and make it run on a daily basis or monthly basis or weekly basis, whatever the team decide to choose, right? um, cool. A lot of data here. So going back to the infrastructure as a code, that's a key component, especially now when every um, company is thinking to move into a cloud, and so they can be more efficient in terms of provisioning these instances, right? So AWS, Azure, Google Cloud, and these are the three cloud providers which are really, changing the game in the market. And you know what's the definition of infrastructure code? Let's read through that. I've copied this from Wikipedia just to simplify that, because it's very important to have a consistent definition. I have seen people using DevOps definition differently, infrastructure as a code definition differently. So it's very important to take the consistent approach, right? So what it says the process of managing and provisioning computer data centers through machine readable definition files. So what are machine readable definition file? It's more of a configuration files, right? So anything that you can consume when you're building or provisioning some instances, and you're creating those test environments, or maybe bootstrapping the instance with a test environment, all of that can be stored in some form of a machine readable definition files. In a world of Puppet and Chef, we call it as a configuration files or config files. So that's what it is. It's an automated process of managing and provisioning computer data centers or the cloud environment through machine readable definition files. It performs systematic control of changes, maybe in a version control system. So it tells you that it's a systematic control of changes. That means it's up to teams to decide on what has to be controlled, what version control need to be used, how often the code should be deployed in what environment. All of that should be systematic, based on your need, based on your environment, and what you're trying to, what kind of test or what kind of application you have, right? All of that. It can use either scripts or a declarative definitions, DSLs, or domain-specific languages. So, for example, if you're using AWS, there's something CloudFormation, and it has its own domain-specific language that you can use to provision environments and stuff like that. Same thing with Puppet. It has its own Ruby-based language. Chef has its own Ruby-based language. And same thing goes with Ansible and Cloud Foundry and so forth. So all these scripting and tooling has their own language. It depends what you want to choose, what use case you have, and stuff like that. I have given some example of some of these systems in the bottom section of this slide, and which embodies infrastructure as a code principles. I'm not saying some of these are better than others. I think it all depends on your use cases, what you're trying to do. I have seen successful applications using Puppet, Chef, Salt, Ansible, CloudFormation, and so forth. Basically the way it works, and you will see in the future slide, it's basically defines the desired states and it looks for drift, especially Puppet and Chef. That's the way they work, and that goes to the next slide. And I think we're done with the diagrams in the slide now. You will see some text, and I didn't want to spend a lot of time in just having those diagrams in the slide, but let's move on. So what is a Puppet? It's open source framework and tool set for managing the configuration for computer systems, right? So it's a Ruby based license, and what they have done is they have taken Ruby as a language, they have customized that language and made their own DSL or domain specific language for Puppet, meaning that any code that you developed in Puppet, it's not going to run in Chef. It has to run in Puppet itself. So it runs in either client server and standalone modes. I'm not sure how many of the audience have used Puppet or Chef kind of methodology. So the way it works is, um, there's a server which is managing all the nodes in the environment, and there's a Puppet client running on all the nodes that has to be managed by the server. So server and client are being constantly communicating with each other, and it can also have a standalone mode for a smaller application, but it doesn't scale well. I wouldn't recommend that, especially for the production instances. I would definitely go for client server where you can easily scale up and scale left and right for your application needs as the customer grows, right? It can be used by managed by configuration on Unix, OS X, and also recently they have, not recently, I would say it's about 2 years now, they have started supporting Microsoft Windows platforms as well. It can manage a host throughout a life cycle. So anything that I talked in the past slides about build, deployment, testing, all of that can be managed with some sort of integration with Jenkins, some sort of integration with other tools that you have seen in the DevOps toolchain slide. From the build to deployment, everything can be managed through Puppet and some sort of integration. All these tools are doing good job and integrating with rest of DevOps tools, and I think that's really important because they want to make sure they are accommodating the entire CI/CD pipeline. um, you know um, some of these things are designed to continuously interact with your host. So for example, if there's a build system is running constantly with every check-in, you and with the larger teams you can easily see 20 to 25 check-ins per day. All those check-ins are creating a lot of artifacts, right? And those artifacts are going in some sort of a artifact management system like Artifactory or Nexus. And it is interacting constantly with the those integration points to show you, or looking for some sort of a drift in the staging environment and all of that. Right. So and what we call it as a puppet master. So server is called as a puppet master, as you would have probably guessed, and client is referred as an agent in a puppet world. um, right? And things are different in Chef, and you will see in the future slide. But in a Puppet, the Puppet master is a server, agents are the client. Agents has their own software installed, which keeps on pinging by giving or sharing certain data to the Puppet master. Um, and uh, Also, client is referred to as an agent. Um, you pull the request from the agent to the Puppet master and run the asset over SSL. You can do that, or you can also have Puppet master execute certain nodes, right? So I don't want to go into detail of how this works because this is not a deep dive session on Puppet or Chef. But just to give you an idea, just to give you some idea on what these definitions are and how Puppet is doing stuff. So similar to Chef, same architecture or similar architecture, I would say, but different concepts. So they call it as a Chef client and Chef server. They don't call themselves as a Puppet master or Chef master. So different way of working, but you will see how these things are being done, right? I'm gonna just skip these things. Give me a second. I think somebody's calling. Hold on. Hello. Okay.